Hi everyone. In this short video, I'd like to give you a real quick overview of the different ways that we draw structures in organic chemistry. So there are three main ways that we draw structures. There's the Lewis structure, there's the condensed structure, and there's the line angle structure. Lewis structures you've learned all about in Chem 1 and Chem 2, and you've probably seen a bit of condensed structures as well. Line angle are new. The nice thing about line angle is they're very fast to draw. They make it very easy to draw big complex structures. The downside to them is they're very abstract. So you really sort of have to practice them and get used to them before you can understand what they mean. So in our class, we're going to start. I've done some Lewis structures this week. For the most part, I'm going to do condensed structures, and we'll slowly, over the course of the term, course of the semester, we will do more and more line angle structures. The line angle are sometimes called skeletal structures. So let's start with the molecule butanol. We'll use N-butanol. So I'm going to start by drawing the Lewis structure of this. All right. There's the Lewis structure. Now, you probably noticed I made a cut in the video because I don't want this video to be too long, but it took me 30, 40, 50 seconds to draw this entire structure. I'd recommend pausing this video, draw it out yourself, and you'll see, you can see all of the atoms very explicitly, but it's cumbersome to draw. So let me show you the condensed structure now. All right, there you go. That one did not take nearly as long to draw. I would pause the video and practice it yourself. You'll see essentially what I've done, and there are different ways of drawing the condensed structure, but I've shown bonds between the carbons, but everything else, I don't show the bonds between the hydrogens. I say CH2, and the reason I can do that is because we know that carbon makes 4 bonds, and so, okay, the carbon is bonded to that carbon, this carbon is bonded to that carbon, these two must be bonded just like that. Same thing with the N, we see the OH. Sometimes you show the lone pairs in condensed structures, sometimes you don't. Why don't I put them in? At times you might not even show these bonds. I think your textbook often does that, so just something like this. Or you might start the first carbon like this. With line angle structures, again, we sort of say, we know that carbon always makes 4 bonds. And so, well, let me just draw out the line angle structure. Quick, huh? I'll put in the lone pairs. Still pretty quick. This line angle structure represents this one. And the reason is, in line angle structures, every angle and every corner represents a carbon. Sometimes we do draw in the carbon explicitly on the end, so I'll do that there. But then every angle represents a carbon, so carbon, 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 carbon. 4 carbons. But we don't draw in the C, we just leave it as an angle. The lines all represent bonds. So if they just end in angles like these, they must be carbon-carbon bonds. This is a carbon-carbon bond because we know that's a carbon, and I've drawn that one out explicitly. This bond right here, here's a carbon, so that bonds to the oxygen. So the other thing is, all right, here is a carbon. We see 2 bonds to other carbons. We know that carbon always makes 4 bonds. Hydrogen is the other most common element in organic compounds. So if we don't see 4 bonds to that implicit carbon, we know that, okay, there must be 2 hydrogens attached because that's what would make it 4 bonds. So each of these 3 things represents butanol. The other rules with line angle structures is you always show heteroatoms. So oxygen, nitrogen, fluorine, chlorine, iodine, any of those. You show them out. And when you do, you always have the option of showing the carbon explicitly like this. That's not a problem. But anything you do show explicitly, like in this case the oxygen and that carbon, you have to show the hydrogens attached to it. You can make a little bond. I could make a bond between these. Leave myself enough room, but I can make a bond or not, just show it as the OH. Or, like this, you can just leave it as CH3. So this is in some ways a combination of the condensed and the line angle structure. You'll also see sometimes written in this combination of the condensed and line angle structure, where you have the carbons attached at angles like this, but you show everything explicitly and you still show the bonds here. So these, let's see, 1, 2, 3, 4, 5, 6 different ways are all ways of representing N-butanol, 1-butanol. And like I said, we'll start with this style because it's relatively fast, but you can still see all the atoms. And as we go throughout the semester, we'll use more and more of this fast line angle structure. The other thing this line angle structure is really good for is drawing rings. So something like that. That's cyclopentane. There are 5 carbons, and it's a pentagon, it's 5 carbons. So the rings are often easier to see than just these linear molecules like this. So I'll see you soon. I hope this was helpful.